Good morning and welcome to this session of EE403 Distributed Generation and Smart Grids. In the last session we had seen AMI or Advanced Metering Infrastructure, and in this session we will discuss about Sanet or Sensor and Actuator Networks. Let us just discuss about this picture. You can see large number of sensors and actuators installed in various parts of the grid. It could be located at the consumer end, at the industrial consumer end, within the microgrid, substations, power plants. And all these sensors and actuators will be connected by wireless or wired communication network to the grid operator, so that we can monitor the grid health and also control every part of the grid. So this is essential to optimize usage of energy. So let us start today's session with a quote by Dalai Lama: "The planet does not need more successful people. The planet desperately needs more peacemakers, healers, restorers, storytellers, and lovers of all kinds." So we are in module 5, and today we discuss about Sanet, Sensor and Actuator Networks. It is basically a network of nodes which sense and react to the environment. As shown in the picture, you can see the essential components of Sanet are a sensing element or a sensor, then a controller, and an actuator with the communication network associated with it. So the major actors in Sanet are sensors, actuators, controllers, and the communication network. Now the communication can depend on various technologies. It could be a RFID or a Bluetooth, a Zigbee, Wi-Fi, or Z-Wave, depending on the application and requirement. And all these technologies, what you see here, is restricted to a distance less than 1 kilometer. Now let us see how we can design a Sanet. Obviously, the design considerations, first is the application. What is the application and what are the required functions, and to realize these functions, what are the required actors. So required functions, you have to consider what are the physical properties to be measured, and accordingly you have to choose the sensor. Physical properties could be temperature, pressure, humidity, so any physical property, and accordingly you have to choose the corresponding sensor. Similarly, what type of physical phenomena or action you have to do, and accordingly you have to choose an actuator. An actuator can be a relay, it could be a switch, and so on. The controllers or the control algorithm also should depend upon the application and the communication, also various standards, protocols depends on the specific application. Energy flow and its supporting infrastructures are sensed by sensors. The sensed data is transmitted to controllers for decision making, and controllers make control decisions, and only actuator can actuate or implement the command. So actuators execute the control task. The major applications of Sanet in smart grid can be classified into three: RE penetration, grid monitoring and control, generation, dispatch and demand side management. RE penetration, renewable energy penetration. See, you must be aware that within the smart grid we will have a lot of distributed generators, and these distributed generators mostly are intermittent and non-dispatchable. For example, sun, solar energy, wind energy. This depends on time or wind. So these are intermittent forms of renewable energy, and proper sensing of their availability is essential to make a proper decision about their penetration into the smart grid. So slowly we are moving towards 100% renewable energy, starting from 5 to 10 to 20. Of course, it will introduce a lot of complications which has to be addressed, but our aim is to reach 100% renewable energy by 2030. And towards that we need a lot of sensing elements and proper coordination between various renewable energy sources and storage systems to go for 100% penetration. Then grid monitoring and control. Each and every part of the grid has to be monitored for its functionality and health, and controlling DERs remotely, that is possible only with sensors and control actuators. Then generation, dispatch and demand side management. These are also important, and proper sensing and feedback is essential to implement them. Now let us see various sensors used in smart grid. So any sensor converts physical properties into electrical signals, or we can say data. So sensors again can sense energy flow, environmental conditions and working conditions. Energy flow, we mean energy, voltage, current, frequency, power factor, etc. And environmental condition means temperature, humidity, luminance, movement, wind speed, solar intensity, smoke and gas, etc. And working condition is again temperature, pressure, speed, acceleration, vibration and position, etc. So these are some of the sensors which are commonly used in smart grid. You might have seen them. And coming to actuators, again actuators basically converts electrical signal to physical phenomena. Switches, breakers, motors, again stepper motors, other types of motors, opening, closing valves, etc. Again, it could be for energy flow, working condition and for user interface. For user interface, it could be display devices, lights, speakers, etc. And for energy flow, it could be breakers, switches, dimmers, etc. And for working condition, opening, closing valves, brakes, motors, and so on. Some of the actuators commonly used in smart grid is shown here. Now the requirements of Sanet actors for different smart grid application. And this again, as we discussed earlier, it depends upon the application, which sensor we have to use for a particular application, what actuator we have to use, which type of controller is important, and what communication protocols and standards are required for a particular applications. This can be again, the applications can be divided into penetration of renewable energy, grid monitoring and control, and dynamic DSM and GD. So depending upon the application, we have to select proper sensors, actuators, controllers, and the communication network. Now these Sanet sensors and actuators, they consume power. So to reduce the power consumption, we have to go for low power design. So each one of these actors should be taking minimum power. So compressive sensing techniques, that is sensing on demand, not continuous sensing. Every sensor should work at a specified time. Then control should be event-based control. The algorithm complexity for calculating should be less, and the data transmission also should not be continuous. It should be in packets at specified time spans. So in total, we should go for low power design in sensing, actuating, controlling, and transmission. We should also look for power harvesting mechanisms, because powering every sensor and actuator all the time is difficult, and also it's not always possible. So we should try to harvest power from external sources like sun, like piezoelectric devices, and thermoelectric generators. And more importantly, the design should be modular and compact. You have what is shown here is a environment wireless sensor, and compared it with a 5 rupee coin. So you can see how small it is and how compact it is, and that is also very important. So these are the references and some of the abbreviations which are used in this PPT. Feel free to contact me for your clarifications. And with that, we wind up this session. Thank you very much.